Okay, new colligative properties. So these are, I'm going to do boiling and freezing point together because they're calculated the same way. But remember, there's boiling point elevation and there's freezing point depression. So boiling point goes up, freezing point goes down. So really what happens is anytime you dissolve stuff, there's the liquid phase is larger. So if you think of like gas up here, liquid in the middle, solid down here. If this is my boiling point and this is my freezing point, it increase, like the freezing point goes down, boiling point goes up. So it's liquid for longer. Okay, exactly what you want to do in the winter. You want stuff to dissolve so that it stays liquid instead of freezing. All right, so boiling point elevation. So solutions will boil at a higher temperature than pure solvents. So anytime you start dissolving stuff, it'll boil at a higher temperature. Freezing point depression, solutions freeze at a lower temperature than pure solvents, okay? So the way that we calculate how that temperature or that boiling point or freezing point is going to change is by this equation here. It's delta T, so change in the temperature of the boiling point, that's what that stands for. Remember, boiling point is going to go up, is equal to KB, and this is a constant I have to give you. For water, it is 0.51 degrees Celsius per molality times molality. This is why we did molality. So the change in the boiling point is equal to, for water per se, 0.51 times the molality of stuff dissolved. Same calculation for freezing point, except the freezing point just goes down. So like by how much does it go down? Well, the change in the temperature of the freezing point, it goes down by this much, equals KF. And for water, that's 1.86. So it's actually easier to change the freezing point times, again, the molality. So freezing point goes down, boiling point goes up. So this is a picture of kind of what that does to the phase diagram. I have solid, liquid, gas still, but it's liquid for longer. So this one moves this way, this one moves this way, and I have a larger liquid section. Okay, so example number 10 says the solution contains 31 grams of ethylene glycol in 200 grams of water. What are the freezing point and boiling point temperatures for this solution? Now, if it's in water, that means the original freezing point was 0 degrees Celsius and the original boiling point is 100 degrees Celsius. So you do need to know those temperatures. I'm not going to put them on the equation sheet. You should know that water freezes at 0 and boils at 100. Okay, so to figure out our new freezing and boiling points, we need to do the molality because that's in both of my calculations, right? Molality is moles per kilogram. So I need to find my moles. So I did 31 grams of ethylene glycol, converted to moles is 0.5 moles per kilogram. I converted my 200 grams of water to kilograms, which is 0.2. So it's 0.5 over 0.2. So the molality is 2.5. Now to find my change in boiling point, change in freezing point, then the molality is the same. So it's 2.5 for both of these. These are those K values I gave you before for water, 0.51 and 1.86. These are on your equation sheet. You do not have to memorize them for water. So the boiling point is going to change by this, and the freezing point is going to change by this. Remember, boiling point goes up. So instead of being 100, it's now going to be 101.275. Whereas the freezing point goes down, so instead of being 0, it is now negative 4.65 degrees Celsius.